I'm going to tell you the story about ROS-Industrial. So, a lot of people ask, what was your motivation? Why would you start an open source software program? The truth is we weren't really intending on getting there. But our real motivation, we're just engineers. And we work for clients, and we want to solve their problems. And we started realizing that the tools just weren't available, and we saw options out there in ROS. And so there's how ROS-Industrial was, that was our motivation. I'd like to talk about our approach to this because it was very different than a traditional approach that we might take, and I think a lot of people might take to creating a program or a new technology. And then I'll talk about the results that came about from that initial ROS-Industrial effort and how really a community has formed around ROS-Industrial. You saw in Sachin's talk, he talked about community around ROS and how important that was. And I think the community that's formed around ROS-Industrial is just as important, if not more so. And then in the end, I'm going to talk to you a little bit about what I think the future holds. What can ROS-Industrial be? And some of those are my personal opinions, and some of those things are things that people have shared with me. And so I'm going to share all that with you. So this kind of all got started back in 2011. And at that point in time, what we were dealing with was really a lack of capability within the software and the tools that you can purchase commercially. At least your typical tools that you would get from your robot vendors or your typical integrators. Some examples of this is that image up there in the top was a client had come to us and they wanted to do this sorting application. And they wanted to do it robotically, and we knew that in order to solve that problem, we'd have to include robots and perception in order to do their sorting application. So what you see up there in that image is a top-down camera view of a pile of trash, essentially, and we've overlaid some 3D data on top of it. And you can kind of understand that you can take 3D data together with a robot manipulator, and all of a sudden you have this very dynamic, on-the-fly sensing and path planning robot that does garbage sorting. It turns out you can't actually buy that. It seems reasonable enough that it should be out there, but it's not. And actually, given what you've seen in Sachin's Move It presentation, you're probably surprised that that doesn't exist, because here it is, Willow Garage has developed this software, it's out there and freely available. It's 2013 now, but it is a shock to a lot of people that this capability just doesn't exist out there in your standard tools. And so we saw a lot of value in 3D sensing, but we didn't see any of the commercial vendors for robot systems providing integration tools for it. So we were left to our own devices to actually figure that out and integrate a system. The next thing I can talk about is the lack of code portability. So Crystal, when she was up here giving you an overview of the work we've done in robotics, she talked about the rack system. And she also talked about the acre system. Those systems, although physically they looked very different, one was a robot on a gantry and one was a gigantic orange robot. Their function was the same, and as software engineers, we should understand that if the function of a system is the same, it shouldn't matter what the hardware looks like or the electronics look like. Good software should be able to deal with those kinds of things. We wrote the software for both those systems, but there's a barrier to actually porting the system, porting from the Acres software to the rack software, and that was that all the Acres software was written in Fanuc's robot language, which is Carol, and we needed to deploy it on a system that had a KUKA controller, which is KRL. And those two languages were different enough that we couldn't just copy and paste code. This should come as a surprise, because today we move code around from different platforms, different architectures all the time. And there shouldn't be this barrier to allow that to happen easily. It turned out to be a significant effort that Jeremy and myself went through. And as engineers, and especially research engineers, we don't like doing that kind of work. That stuff should just happen. Manually porting software is not really where the value is for any of us in this room. Another important component that was missing for that application is we're using this rack system to strip paint off very expensive fighter aircraft. And we don't want to run into that aircraft. That can be a multi-million-dollar incident. It turns out for that system, we solved it mechanically. We provide bumper switches all over the robot so that if and when we do run into something, run into a plane with that robot, the robot would stop and it probably wouldn't be a big deal. But it's a shame, after seeing what Sachin has shown you, that the software just can't be aware that there's a plane right there and that the arm shouldn't be moving in that space. But in 2011, we just didn't have that capability. The bottom picture is the Mr. Rome project that Paul Voss and Glenn Bartlett actually led up. And that was an effort to integrate mobility and manipulation for industrial platforms. This is something that universities have been doing for a lot, but it hasn't really found an industrial application. And so what Glenn and Paul were trying to do was find an industrial application, show that there are huge work volumes that can be solved a lot better with a small mobile platform rather than that large orange robot that you see, right? And so in order to do that research, they had to integrate a mobile platform, an industrial robot arm, and an external referencing system called iGPS. We spent a lot of money doing that, and in the end, it wasn't a pretty solution, and it was just very costly. And then finally, once we got all that stuff integrated, we had this mobile system, and we didn't really see any support for it in any of the commercial packages, right? The people developing the mobile base and the people developing the arms weren't thinking that these two things would ever be married together. So these are things that you've all seen Sachin just present, that he has tools that solve these problems. So you can see how there was a capability gap, and we saw how ROS was an enabler for all that. In addition, as being a researcher, there's a tremendous amount of frustration when you look at what's in the university systems, what R&D research is going on, and what you can actually deploy on the factory floor. And initially, there was a lot of work being done in service robotics, right? Which is a small commercial sector of robotics. Industrial robotics is where the business is, right? That's where the money's made, but there wasn't a lot of academic research being done at that point. Certainly not research we were aware of. Now, through this ROS-Industrial initiative, we found out that there are people doing industrial research. But I'd still tell you that it doesn't make sense that there isn't more, given that industrial robotics is where a large portion of the money is made. So what we saw in 2011, and still exists today, is that there's this gap between what universities can do and what we can deploy on the factory floor. And it's gotten larger in the 8 years that I've been doing this. That's not a good thing. You'd like it to get smaller. You'd like it to be easy to transition tools from academic research into actual applications. And also, we were frustrated that a lot of the powerful software engineering tools, things like debuggers, some complex libraries, all that stuff was kind of missing, because every industrial robot and other industrial platform typically has their own closed development environment, which doesn't allow you to leverage a lot of the tools that exist openly. And then also, it's worth noting that it's a problem with the business model that makes it hard to innovate for industrial vendors in general. it's not that they don't know this technology exists. I mean, they're perfectly aware. When I went to go visit them, they understood that, hey, this is state-of-the-art research that's going on. Their response was, we just don't have the resources to integrate it. And there's two reasons for that. It's a fragmented market, right? There's lots and lots of robot vendors. There's lots and lots of sensor vendors. And nobody really has the size or the scale to actually fund an effort. Certainly not what you see on the scale of ROS ever going on. You'd never see that happen because the companies are too small. And for those companies for all those companies, they're really only focused on very large existing clients, right? And if we're going to push the state-of-the-art in technology, that's going to be in these fringe areas, right, where the growth is really going to be. But again, they're not, because they're focused on large customers, which is currently automotive companies, you don't see them pushing the technology in that direction. So I've talked about this capability gap, and you've already seen, based on Sachin's presentation, that ROS and MOVEit can address those things, and we saw that as well. I've talked about frustration with this gap between academic research and what is actually deployed, and that's something ROS comes in and helps. One thing that Sachin really didn't talk about too much was that when he talked about the ecosystem, it's actually huge. I mean, if you go to an academic research institution, odds are they're using ROS to do their robotics research. So if we can adopt the same platform that they're using to do their research as for us to use in our applications, it'll be very, very easy to transition that technology. And ROS also addresses this business model problem because ROS is at such a huge scale and because it's open, right? So we have two choices in order to solve this business model problem. We adopt something open like ROS, or companies start consolidating. And in the last decade, they haven't consolidated. So an open solution might only be the only option. This is why we think ROS-Industrial is different and why it can be successful. So I've talked about how ROS solves these problems. There are other solutions. I often get beat up because I say, ROS does things that other software technologies can't do. And that's not entirely true. There are high-end and niche solutions. There are several small companies out there that have developed very capable software packages that can do similar things. I wouldn't call them complete solutions by any stretch of the imagination. Maybe they focus on path planning or manipulation, but they lack perception. But they do have a lot of capabilities built in. ROS is more of a complete solution, right? It's broader because it's larger. It has larger scale. So it can address things like perception and computer vision and path planning and core architecture, those kinds of things. The problem with the high-end or niche solution is it's 50 or 100K. So, that makes it very limited where I can deploy that solution, right? If I have to pay 50 or 100K just for the software, how many people are going to be able to use that? Well, again, it's probably those very large customers that are well served by today's market. If we think small and medium-sized companies are the companies that need innovation, and through that innovation we're going to grow the market, we can't be charging those companies $50,000 or $100,000 just for the software to run their robot cell. And also, for these smaller companies, the lines of support are uncertain. You saw a Robonaut up there. We went and talked to NASA, and they had a robot operating system, not ROS, but something else that was running in real time and controlling Robonaut. And the company went out of business. And they couldn't do anything, right? They were stuck with the last revision of software that they had, and whatever bugs were in it, they couldn't do anything about it. That could easily happen to one of these other small companies that have these niche solutions. But the great thing about ROS is if a company goes out of business and they've open sourced their software, then you at least have access to that. And somebody might come up in their place. So there isn't this chance that a company is just going to die and you're going to be stuck with a legacy product that doesn't do what you want. So the other solution is how we worked for years. Southwest Research does contract research. You have a hard technical problem, we'll come and solve it. We'll do custom development. Those are the kinds of projects we like. We like to do custom development that solves hard problems. But it's an expensive solution, right? And we're so focused on solving the very specific problem our clients have that we don't develop these broad capabilities. So I can almost guarantee you that the work that Sachin and Shaun have done would never have resulted of a specific project work that we would go after, that was application focused, right? Because they were developing broad capabilities. We're always focused on solving problems, our clients' problems. So I hope after seeing all this, you understand why our approach was we're going to leverage ROS for industrial applications. For all the reasons I outlined, ROS is the reason, or ROS is the solution, or the best solution to those. And we called that ROS-Industrial. This was a little bit different for us, right? We had to learn a couple of things in going through this process. And I was lucky enough to go to Willow Garage and learn from the people who understood this. That we should really stand on the shoulders of giants, right? That means we leverage capability within ROS and all the other open source packages that it uses. And we can benefit from that. So, one thing that we had to learn is that other people can develop technology. I hear a lot of not invented here type attitude. And to a certain extent, we had that, right? There are smart people that work at Southwest Research. I like to think I'm one of them. Maybe I am. But there are very smart people that work elsewhere too, right? And so their technology is just as good as ours. We had to learn that our resources and other people's resources are limited. So even though we think we're all very smart, we're only going to be able to achieve so much separately. Not all software is intellectual property. When I first started engineering, I talked to an IP lawyer, and he told me that if you as a client paid me to do something to develop software, that had value. That made it intellectual property. And even at that young age, I didn't really believe it. And now I believe that that's not true at all. Or that at very least, there may be IP or intellectual property value there, but the benefits that I get from giving it away far exceed the small value that I put into it, essentially. Things like releasing drivers and releasing perception software and getting other people to use it and submit patches back and improve your software and release that into the open source ecosystem. The value that we've seen in that and stuff coming back to us far exceeds the value we ever put out into ROS-Industrial. And finally, we needed to learn that being open can be a business model. You can make money off of open source software. Part of that is you have to recognize what value you bring to the table. It's not necessarily developing that software, but for us, it's solving people's real world problems. Right? The software is a tool, but we bring our expertise and our resources to bear on people's problems. So ROS is a solution to all of this. It's open source, it's BSD licensed. That means myself or anyone in this room could take it, use it however they want, and not have to share anything back with the community. So it's definitely considered business friendly. It's open architecture that Sachin touched on is very helpful when it comes to sharing resources across the open source ecosystem. It ensures that if I develop a path planner that works with Southwest Research's particular application, that I can put it out in the open source ecosystem and it's going to work in Sachin's Move It, right? You've already seen the capabilities and tools within ROS. The things that Sachin and Shaun have developed in Move It are extremely impressive. We actually use ARM navigation, and now I'm really excited to transition all of our stuff to Move It, given what we've seen. And I can't talk enough about the scale of ROS. It is by far, it's larger than any one company could ever have developed, put into a particular product that would do the same thing. It's very amazing. So, I'm going to stop it. All right, so what did we actually achieve when we did this? So I went to Willow Garage and I basically integrated ROS with industrial robots. And I set up a framework for doing that. It's very, that was our initial step in the process, and we wanted to show people what was possible. And because people see the videos of the PR2 and they didn't quite believe that I can make a robot, an industrial robot, do the same thing a PR2 does. So a lot of what we've been doing in this early development is just showing people, here's a ROS capability via ROS-Industrial, here it is in an industrial application. So what you'll see is a demo that we did at the Automate conference.
To showcase the advanced capabilities of ROS-Industrial, Southwest Research Institute conducted an interoperability demonstration at Automate 2013 in Chicago. The demonstration work cell has robots from 2 major manufacturers controlled by a single program. The 2 robots collaborate to pick parts from a randomly cluttered pile, identify each part, and sort them accordingly. The process is driven by point cloud data from 2 3D sensors located overhead. The system is not pre-programmed. It makes decisions in real time based solely on the current data stream. Once the parts are sorted, the process reverses to automatically reset the demo. Parts dropped down the ramp pile up randomly in a cluttered heap. To help with programming and debugging, the developers used one of the 3D visualization tools from ROS called RViz. It fuses 3D world model data with 2D and 3D data from the sensor data stream. The visualization updates immediately as the robots move. To learn more about ROS-Industrial, please go to rosindustrial.org.
So in giving that demonstration at the Automate conference, we showed people, hey, all this ROS software, all this cool capability, it works on the robots you're used to seeing. And we got a lot of great feedback from that conference, and some of you that are here today are because of that. So once we figured out that ROS would be very useful for industrial applications, the next thing we did was brand it. And I get a lot of questions, how is ROS and ROS-Industrial different? They're different because they have to be different. In the industrial world, we want stability, reliability, robustness, right? ROS is all about cutting-edge technology development. Those two, if we try and force them into the same bucket, it's not going to work very well. We also, if we go to people and say, hey, there's this ROS software, and they say, I understand that as a tool that a lot of universities use, it's a hard sell. Because if somebody is in industry, they may not want to use a university tool. So ROS-Industrial is meant to address both those. We're using ROS-Industrial to create a stable, reliable version of ROS that meets the needs of industrial uses and industrial applications. And also gives industry ownership of it. So it is something different than just a university tool. The other thing we've done is build a following, build a community through events like this, having public meetings where people can show up and learn about ROS-Industrial, and we can tell them what it does and why we're doing it. We also did one last October in Germany at Fraunhofer IPA, and that's how we've become sort of a worldwide organization with ROS-Industrial being supported at Southwest Research and Fraunhofer. Okay, so what actually happened after we went through all this process of creating the ROS-Industrial program? Well, we learned from Willow Garage that media attention is a good thing. And so we've actually got quite a bit of this. This is the MIT Technology Review, IEEE Spectrum. We have a control engineering article, and the everything robotic in the robot report. These are well-read online kind of news outlets, and they see the value in ROS-Industrial, and if we can push the information out to them, that broadens the audience, right? So that we can create this bigger community that we're talking about. We have a worldwide following. These are people all around the world that are users of ROS, that have contributed stuff back to ROS-Industrial. And it's by no means what we ever imagined when we started ROS-Industrial, but it's the power of this open source, open approach. And this one's just as important as the open source community is, what does industry think? What does the government think? Because ultimately, funding for these things and direction for ROS-Industrial needs to come from industry and government, particularly industry. We want to solve industry's problems. That's how Southwest Research works. If we're going to create this open source program, we want it to feed into industry. So there are a lot of companies that we've talked to and expressed interest in what we're talking about and expressed interest in using it even. Along those lines, we're starting the ROS-Industrial Consortium, and I'm not going to talk about it too much because Paul Voss is going to tell you more details about it. But again, this is the idea. We want industry to have their say, and the ROS-Industrial Consortium is a way for that to happen and a way for them to develop the technology that's important to them. So with all that, where do I see ROS-Industrial going? Well, I think there will be industry adoption of ROS and ROS-Industrial in the future. There are companies that are using ROS today, and through the ROS-Industrial Consortium and meetings like this, I think ROS-Industrial will be pulled into industrial applications. At first, it'll be in the R&D level, right, where people are proving out processes using the powerful tools within ROS-Industrial to do things they couldn't otherwise do, either on a fixed budget or schedule time frame. And then I see ROS-Industrial moving to the factory floor and actually doing real work. I think it'll be early adopters within the next year and a half that will actually have ROS-Industrial deployed on the floor doing real factory work. But I do see that is going to happen. I'd like to see in the industrial market the acceptance of open source as a business model. This isn't something, it's something that in the technology and web technology areas, markets, they understand. In the industrial world, we don't really understand it yet. But if we look at the people that have accepted open source business models and how their markets have grown and diversified, we can gain some lessons from that and hopefully adopt an open source solution ourselves. I do believe that ROS-Industrial is going to broaden the capabilities of industrial robots, what you can get what you can get commercially. And by doing that, by broadening that market and solving problems that are in the small and medium-sized businesses and some of the niche areas and the large manufacturers, the entire robotics market will grow. So whereas today, some robotics vendors may look at us and say, oh, well, it's somewhat competitive to what we're trying to do. We don't try to be competitive. We don't replace their technology, but some of them still see that. The argument can be made is, even if you feel that way, if I make you more money by broadening your market, can you get over it? And yeah, I think they will. I also hope to see the scale of ROS-Industrial reach the scale that ROS has. I've seen the tremendous technology that can be developed as a result of that. Growing that worldwide following is very important to us, and I see that happening. And then finally, I talked about one of the big frustrations is the gap between industrial applications and the research being done at universities and research labs. Through ROS-Industrial, adopting this common platform, I see that closing. And I see things, I see being able to deploy a technology that came out of university 6 months ago, deploying that on a factory floor and doing something new that we couldn't do before. I believe that'll be a reality. And there is a gigantic picture of me. Any questions? Or?
Can we ask a question?
Yeah.
Yeah, at any time. So my question is more related to open source. When Azure made a controller and we were studying in China, I had to go to Department of Commerce export control law that was restricting giving the freedom that the control of a certain mechanism of which can give you the freedom that is prohibited.
Mm-hmm.
And that's the reason why Rockwell only has free access to kinematics, because it's certain controllers worldwide, and they can export controllers more than that.
Yeah.
So the question is, in ROS, obviously, you're not only exporting a package, probably even the source code too. I wouldn't even start the source code to say the capability to do it. There's no implication under the Department of Commerce. It's not ITAR, but the Department of Commerce export control law, which is prohibited.
Mm-hmm.
How does this fit in there, especially for industrial manufacturing applications? So if something can be used in a manufacturing sense, that's a no-no.
Yeah.
Who watches out for that in the open source world, and what does that mean? And you're putting it on the web, somebody in China is probably, North Korea is probably downloading it right now.
Mm-hmm. So everything that Southwest Research has developed doesn't necessarily fall within that realm. We do have export control people that we can talk to and discuss that, discuss with them those things that they're worried about. Part of it is, that's why we've engaged industry. We need a central organization to manage those kinds of things. And so that is what the ROS-Industrial Consortium is supposed to do, is not only provide a way for industry to give their input, but also manage the ROS-Industrial software. And if we run into problems like that, that's the group that's going to solve them. Some of the things you're saying.
I think the biggest concern for industry is once their name is associated with it, is there any implication of liability because of that? Because it's part of the consortium. Now, when somebody in the Department of Commerce wants to come after it for some reason, they're associated.
Yeah.
Otherwise, open source is all over the place. You don't even know who to go after it. Now there's an entity associated.
Yeah, I think I'm not really the guy to talk about all those details.
But I'm saying that once an entity latches onto it, even though you have done nothing, it's too much.
Yeah.
If somebody can go after it.
Yeah.
Yeah, really guys doing manufacturing robots, industrial tasks, with this kind of software.
Yep.
So let's go after them because they can't claim anybody else.
Yeah, and so that is the need, that demonstrates to me the need for an organization, right, to minimize the risk. I mean, that's what you can do with that kind of stuff, is you can only minimize the risk of those things occurring. That's how the organization is supposed to function. Now, I'd point to a lot of technologies, encryption being one of them, that had similar issues, and that didn't really stop it from being an open source program. There are ways to.
The argument with the Department of Commerce and KUKA sends the work to China and Iran all the time. They have
Yeah. Yeah. So. Yep.
I just had a question about kind of the goals for us. I know that right now there's a lot of focus on like the robotic control, path planning, the tools and things like that. Is there any plan for like factory integration to integrate with like manufacturing systems, reporting out status for robots, things like integrating planning into ROS and things. When I say planning, I'm talking about like build instructions, anything like that.
So I can talk about the near-term plans are especially with ROS-Industrial, is to integrate with other things outside robot controllers, PLCs, SCADA systems through OPC. Those are the things that we'd like to do next. And then as far as kind of higher level, maybe MEP systems, or I'm sorry, material requirements planning systems, that's something we're looking for the consortium members and other people outside the consortium to provide direction on. What are the tools that you use, and how would you like them to be tightly integrated with your robot systems? All that being said, if there is a commercial solution, we don't replace commercial solutions. We just make our stuff work with it. And so we're not in the business of redeveloping technology that's already out there.